Oh, it's streaming live on YouTube. Cool.
Yeah.
We'll handle.
Now I'm working on this. Yeah.
Cool. My team will handle that in the future. Yeah. Cool.
Yeah. Okay. I'm still waiting for the permission.
Permission for what?
For sharing screen.
Oh, okay. Yes. All right.
Okay. Sure. Okay. Can you guys see my screen?
Yes.
Uh-huh.
Yeah. Clear.
So welcome everyone. Yeah. So for the JinaD, we actually have already covered this topic 2 months ago at the beginning of in our episode in January. In December, maybe in December. Okay. Anyway, so we have done a lot of refactoring on the JinaD. For those who are not familiar or haven't heard about JinaD, let's have a quick introduction for JinaD. So JinaD is short for Jina demo. And it's supposed to be a persistent process that can help us deploying and managing Jina in distributed system. You may think about JinaD like a native way for orchestrating Jina instance. But here I will put a diagram. So think about you can have your flow running locally. And meanwhile, you want to have some part of your flow, some pod, which is doing heavy lifting work. And you want to put this part of work on some remote machines. Maybe you got really good bargain from the cloud services. Then you can simply put this part of heavy lifting work running on the remote. And all this can be easily done as long as you have a JinaD process running on your remote machine. Yeah, we want to revisit this part because we have done quite a lot of refactoring and cleaning up the APIs for running JinaD. Plus, previously we actually hold a separate repository for JinaD, and right now JinaD is included in the Jina repository. You can find all the source code under the Jina repository. And every release of Jina, we will release the JinaD, we release the Docker image together with Jina and JinaD. For installation of JinaD, we recommend you to use the Docker image because the JinaD when you want to run the JinaD and visualize the logs, we're using FluentD to collect logs from different distributed machines. And using the Docker image will save you from the trouble of installing FluentD separately. As you can see, once you have this JinaD Docker container running remotely, you will have JinaD and FluentD running in your container. And JinaD has several ways to start the instances. It can either start the Jina instance locally on this remote machine, or it can start the flows on another remote machine. And you can start Jina Flow, Jina Pod, or Jina P with JinaD as you wish. Yeah. Okay, so next part, I will show you a very simple demo of how to use JinaD. So previous, I've already deployed JinaD on this remote machine. And you can check out the status by typing the IP address, the port, plus the API status to check out whether your JinaD is running properly. As you can see here, my JinaD is under the version 1.0.8. So the version of JinaD is always the version number of JinaD is always the same as Jina. And now let's start running some examples. Yeah. Today I will just use our examples on the README page. So in our lovely README, we have the very simple example about indexing for documents. So the copy paste here. So here we define 4 documents, and each of them has a corresponding embeddings. Yeah. Then we say, we want to build a flow. So here we define a flow and just add one simple pod to do the index. Then we can use this part to index data. So with this line, it will build the flow and run the indexing. Afterwards, print the result on your screen. Then we say, okay, we want to search. We want to search the builded index with one of the document we have our index. Then when the result is retrieved, we just print out the matches. So now everything will run locally. Let's just run it. So as you can see here, it said everything is stored locally under the .simple index folder. And by this point, we index the data. And afterwards, we start searching. The result is printed out here. We fetch 3 results back. And as you can see here, so locally, we have one folder generated from running this script. So under this folder, all the index are saved. The chunk file or the vector, the chunk file index the meta information, and the vector part install the vector data. Now we can easily remove this. Now let's start using JinaD. So instead of index the data locally, I want to put the index on our remote machine. So let's remove this folder for the time being. And we can simply say, hey, I want to put this indexer on the remote machine. And let's check out the address of our remote machine. So here in the host argument, I will put the IP address plus the port of my remote machine. Then we can simply run it again. We will see locally there won't be any indexer file generated, but still we can retrieve the results as before. As we can see here, the pod, the flow is connected to the remote machine. And here, there won't be any index file generated locally, but still, after indexing the data and running the search part, we can still get the result back. Yeah, so you can find more information about the JinaD on our README, and you are welcome to try out JinaD by yourself. So for the people that don't want to maintain all the decentralized distributed trouble by yourself, you can simply use JinaD to distribute your Jina instance. Yeah, that's the part from me, and I will hand over to our next speaker.
Yeah, and in addition, if you want to use JinaD on an AWS instance and we want to customize that for our needs, like the type of instance, and maybe you want to use a machine with a GPU or something, we have published a Terraform module, and the usage is mentioned in the chat box. I pinged the link, so feel free to try that.
Mm-hmm. Okay, so Paul?
Yeah,
you can
shall I
start
continue?
sharing. Yeah.
Good. Can you see my screen?
Yes.
Yep.
One moment, I will switch to slides. So my name is Bo Wang. I'm an AI engineer working at JinaD.ai, and I'm going to give a little bit very short and quick demo on the CLIP, which is controversial language image pre-training model. And to give a little bit context on that, basically in Jina, we have implemented something previously. Maybe you have already noticed in the Jina examples, we have a project called cross-model retrieval example. But now, because OpenAI just released the model called CLIP in maybe January 6th or January 16th, so it's pretty much very latest research result published by OpenAI. So they open sourced their project and open sourced their paper. And it is very, very promising and interesting to build a model trained on CLIP. So we did that in the last week. So the model was released in late January by OpenAI, and it was trained on 400 million images text pairs collected from internet in a weakly supervised fashion. The way I mention it as a weakly supervised fashion, because you can imagine it's not just feasible to allow humans to annotate or labeling so much amount of data. So we say it's weakly supervised. And this model applies zero-shot transfer to downstream tasks. So basically, the model developer from CLIP has tested on different, maybe 20 or 30 subtasks using the pre-trained model. And a lot of tasks has surpassed the previous, models on different kind of tasks, such as image classification or retrieval tasks, question answering tasks, such as visual question answering on image and text dataset. And so in our case, because Jina is like a neural search company, so we want to apply this kind of CLIP model to our context, that is for the cross model retrieval. In our case, we retrieve images using a piece of text and to see the results. And if you want to try it out, you feel free to do that, because we have already published an app on GitHub. You only need to run 2 lines of code to make it work locally. So first, you we have pre-indexed our model, the clip model, on the Flickr dataset. So you only need to Docker pull our Jina Hub app of cross-model app. Then after that, you only need to run the app by Docker run-p, your port number and the app name. Then you can open Jina box and just update the local endpoint as your local host, and you will see the result. We did some internal evaluation on the clip model because we are quite interested to see if the clip model performs better than what we have done before. There is a model called VSE++, was released by someone else like 1 or 2 years ago. So according to our evaluation using the mean reciprocal rank, we see that clip model outperforms than VSE model on a subset of around 4,000 like Flickr images. And this is worth to mention that because clip was basically trained on an extremely large dataset, so it's not trained on Flickr dataset, but VSE++ model we are using was trained on Flickr dataset. So already clip, the performance of clip already surpassed VSE, even it was not trained on the specific dataset. So we see clip was very, very powerful. And I'm going to show you how it works and in how it looks in Jina box. So I have basically pre-indexed all the Flickr 8K image dataset. It is an academic dataset collected from Flickr. And I already started the Jina query flow. And I'm going to go to Jina box. Actually, I have pre-selected some queries to just better illustrate the idea. Some difficult queries. So maybe a cat and a dog. You see the result already showing up in the screen. I don't know if you can see it clearly. So the top 10 results, a cat and a dog. Cat and dog. Maybe this is 2 dogs, I don't know. And some results also showing up because it is worth to mention because this dataset only consists of 8,000 images. Maybe when you see something weird, it's not because of the model is not working. It's because our dataset simply do not have that much data. Oh, maybe I need to rerun the flow again because I clicked something strange. Let me start the query flow again. Yeah, now it should be there. And I'm going to query something else. Maybe a bird flying over sea. We'll see the result. It's really, really good result, showing a bird flying over sea. And maybe a dog. So it shows human walking dogs on the street or in the park. And I'm going to try some maybe an even difficult query. Men wearing glasses. You see the result. It's showing some people have glasses. And the results are pretty good. Maybe if we try to search for basketball player, you see we got basketball player results. What if you might be curious that what if we have some typos in our query? Maybe I can just maybe change A to O, basketball player. It still returns relatively very good result actually. So it can also handle typos very nice. And if we just do another query of maybe query extension example, maybe sometimes when we query car racing, you might see some car racing images. But if we add some new like keywords called F1, you'll get basically F1 racing images. But the rest of the images might not quite maybe related. It's only because we don't have so much data in our 8,000 images in the Flickr 8K. So that's basically it. Do you have any questions on the Flickr implementation?
Where can our lovely community go to try this out for themselves?
Yeah, if you are interested, please just run the demo locally. You just only need like 2 lines of code to make it work locally. Or if you wanna like train your model or encode your model using Jina, we recommend you to take a look at Jina examples. There is a tutorial on our website called Development Guide, Add New Executors. Basically, we have added an example of how to customize an executor in action, adding a clip encoder. This is basically what we have done in our team, trying to illustrate you how to encode create a new model in Jina Hub using exactly the same example as what we demoed here. So please check out if you are interested in create your maybe customized encoder and decoder. So basically that's it.
Yep, and you can find this also on our examples repo, right?
Yes, you can also find this in our example repo. It's in Jina AI examples. Then if you go to cross-model search, you will see how did we design the index flow, the query flow, and everything else. We have a very nice and comprehensive like README file inside this example. If you just follow the README, you can run the example locally as well.
Just be sure that you have a lot of disk space because the image weighs 11 gigabytes and you'll need a fair chunk of memory for this as well. It's quite computationally intensive.
Yeah, that's true. Thanks for mentioning that. Do you have any questions? Okay, maybe no. Maybe we can go to the next demo, I guess.
I guess then it's me. Oh, I like this example. Thanks a lot, Bo, for sharing.
Thanks.
Then I will go and tell you something about the traversal refactoring. Let me share my screen. There we go. Let me make it a little bit smaller. So here we go. So I talked about the traversal already before in the all hands, I think 4 months ago and 2 months ago. And we had the recent refactoring once again, and had the motivation was we wanted to have performance improvements for massive data. And what do we exactly want? So imagine you have a document, let's say a text, and this document has paragraphs, and these paragraphs have sentences. And then the text usually not have just one paragraph, but multiple paragraphs. So you could say, okay, this document have multiple chunks. And these chunks again have chunks, somehow chunks on a more granular level. And so a text could have easily 100 sentences or so. And then you could also imagine, okay, I not just when I want to index something, index one text, but multiple texts, and each of them has a lot of sentences. And let's say I want to index in each batch 10 documents, and each document has roughly 4 paragraphs, and each paragraph has roughly 5 sentences. What we in our old version would do, would have 40 calls to the encoder, and each time with 5 sentences. That's what happened until now. And this is kind of nice. The encoder can always do these 5 sentences in batches and somehow make at least them together. But for a typical encoder, it's always good if you give them bigger batches because they can calculate the encodings much more efficient on bigger batches. The same holds true for when you want to do synthesizing, that might hold true. When you want to index something, that might also hold true. So whenever you do something which way you can do nice matrix multiplications in NumPy, you want to have bigger batches. And ideally, in this case, we want to have one call to the encoder with just all 200 sentences at once, because then the encoder can efficiently encode all 200 sentences in one go. And especially latest when you go to GPUs, that gets really fancy because then you get can really leverage the speed of the GPUs. And yeah, that's somehow what was the motivation behind it. That before this was not really efficient, and there was no way of getting the bigger batching. Whoop, part of the slide did not load. Why this? Show anyway. Why is this not loading? Okay, then I just go here. So what happened beforehand? Let me try if I can present once again. Okay. They also, Google changed their interface. When you click on present, it doesn't open in a new window, but just full screen the current window. Buggy. Well, that's with new software releases. So before, when you think of a document, this is our, if you have never seen this kind of tree, let me explain short what you see here. So the red nodes is the root node. So it's just a document that you put in. Could be, for example, a text. And then after you, for example, got the paragraphs out of the text, this text might have children, which are chunks. And since the document has somehow the ID 1, the chunks may have the ID 1.1 and 1.2. And when these are paragraphs, it might also be that I want to have sentences, and then I have each of these paragraphs again is put down into sentences, and somehow this is like a nice tree which goes up until the root document. And what happened before when we called this apply all, which is our interface between our drivers, which do all the internal document handling or internal data structure handling, and our executors, which are our actual algorithms, which do calculations of the data. On driver level, somehow we had this call. And what happened here is we got documents, which would be, for example, on an encoder level, the chunks like the 1.1.1 and 1.1.2 together. And we got the context document, which is the 1.1. And this is somehow what happened until now. And the reason for this is sometimes when you do calculations on the somehow, for example, the sentence level, sometimes you need the information of the paragraph. For example, when you want to do ranking and you want to take these scores and bubble these scores up somehow, let's say you've scored in the ranking process these sentences, but in the end you want to score whole texts, then you would first take the scoring of the sentences and combine them to a score of the paragraph. And afterwards, when you have scored the paragraphs, all of them, you would bubble them up to score the full document. And for this, somehow you need a context. That makes sense. But when you think about encoding, you just care about the sentences. So you don't care about anything that is of the structure that is above somehow the level here. And so there is no point to differentiate into this construct on the left-hand side and on the right-hand side. And that's why there was this motivation to refactor things. But until now, we always had this, okay, all of these somehow family of chunks would have been given to the encoder together, which were, when you go back here, these 5 sentences, more or less. And now we say, now let's get all the 200 sentences at once. And for this, we had a refactoring, which we implemented via mixins, and each driver somehow can decide which mixin it needs. Because for some drivers, we still need the rich information with the parent, for example, for the ranker driver, but for some drivers, we don't need this rich information. Or you could also think about, so we don't need, for example, for the encoder driver, this non-rich information. There we use this flat recursive mixin. And also the apply all, the function definition changed. We don't get the context document anymore, but just documents, which is just one big list of documents, which can then be encoded at once. This is somewhat flattened. And then we still have the possibility to have the old structure, but also there changed a little bit. Then we use the context-aware recursive mixin, this one here. You see my cursor, right?
Yes.
Ah, perfect.
Yeah, we see it.
So for example, for the reverse QL, what does the reverse QL do? When you give it a list of chunks, it should reverse them for the parent document. Somehow this changes the data structure. And for this, you still need the structure of the parent document, that you can't just give it all. For example, when you always want to reverse texts of one paragraph, you don't want to reverse all 200 texts. You wouldn't even know what reversing means there, but always 5 texts in a row, somehow in a batch. And that's why you still have the possibility to have this context awareness. And here you get not now documents and a parent document, but you get doc sequences. And each of these doc sequences is in the end one of these pairs. But let's go into detail what we mean here, how this exactly looks like. So let's go first to the flat recursive mixin. Here you see again our tree. And as I said before, we now get all the sentences from below as one somehow in this apply all function. And when we look into this apply all function and say, okay, traversal path is CC, which means please apply this function to the chunks of chunks, so the ones down here. The docs would be a document set of all of the chunks. Any questions so far?
So far, so good.
Okay, then let's go further. Now for the context-aware recursive mixin, we have these document sequences, which is an iterable of document sets. So here again, we get these batches. And we don't get the parent document anymore, and there's a good reason for it. When you look at now at the right-hand side, can we increase this a little bit? Let's do it at least like this. Now it's a little bit bigger. Now you see here, there is, when we use also again the traversal path CC, so we want to apply it to the lowest level of chunks, then we get now an iterable of first the one chunks and then the other chunks. And then also the document sequences, which is all this iterable of 0. Okay, that doesn't make any sense because it's an iterable, but imagine it would be a list. So the first element is actually the chunks of these chunk, so the subchunks here. So when you manipulate this list, this doc sequence of this, so this first list, you actually manipulate the chunks of the list, chunk list of this document. So when you reverse this document set here on the right-hand side, you really reverse what is written into this chunk. So you have full access to the document structure. And you even can get the parent document via the reference doc. So when you have now this whole list of chunks, you can do .reference doc and you get the parent. And I talked now about chunks the whole time. This is also true for matches. So if that would be matches, you could also get the parent via the same reference doc. So far, so good. Let me put these two somewhat side by side once again. So when we have a traversal path where we want to say, okay, just apply it on this chunk of chunks. So on my initial example on sentence level, then we would, on the left-hand side, we somewhere on the flat, we get a flat list and we can give all of them together to the encoder, and the encoder can do the nice batching where we get a speed up. But if we need the rich data structure, because we want to manipulate this rich data structure, we have still the possibility to get them one by one and even get the parent document. So far, so good if we want to do things just on one traversal path. Now things get a little bit more tricky when we do two traversal paths. So let me stop again if anybody has a question until now before I go on. Seems like I can go on. So now imagine we want to have a segmentizer, or let's call it synthesizer. Oh, no, segmentizer. Segmentizer was good. And what we do is we have a image of 400 times 400 pixels. And now we want to, on the first level of chunks, we want to somehow have the pieces of this image 100 by 100, which is a quarter of the image. And by the next level of chunks, we want to do it 25 by 25. So that means CC means first. Oh shit, this should be. I'm sorry, this is a bad example. It should be R. I'm sorry, it should be RC. Because I first cut the root document somehow, the 400 pixels down into smaller ones. And afterwards, I cut the chunks down into smaller chunks. So it should be RC. But for the sake of simplicity, let's imagine we have already somehow, these are already the chunks. And I want to break them further down. So this is chunks on level 1.1, and this is chunks on level 1. So I'm sorry, that was a little bit confusing. Let me go to this example to explain what I meant. So imagine I have the document already. Now the firefighters are going out just beneath my house. I hope you don't hear it too much. So when you have a document and you have chunks, you want to break these chunks down into smaller chunks and then again down into smaller chunks. Then you would say, first break me the first level of chunks down and then the next level of chunks. The traversal path would be C and afterwards CC. And the segmentizer uses the flat recursive. And what you would get is not all of them as one batch, but 2 batches. So I said before, here you get all of them in one batch that somehow, for here the encoder can be really effective. But if you have multiple paths, you get one of these sets per path. And the reason for this is, if you want to do exactly these first segment 1 and then the next one, if you would compute the full set at once, you wouldn't be able to get here any data at all. And that's why you get first somehow the chunks and afterwards the chunks. Who has questions?
I have a question. How do you arrive at the quarter of the image? Is it like default setting or?
Yes, that's somehow the segmentizer, I say, and let's say we have here the segmentizer says what is the some parameter, let's say size split factor, and that would be 4. And then would you say, okay, it's a quarter of the image. So that's a made-up example. You could also say this is a tenth of an image, or this is whatever is your segmentizer does. So my main point here is you have something which you want to apply twice in a row, and when you apply it before you do something, the chunks of chunks are not even existent, because when you apply the segmentizer on this level, you just have chunks, but not the sub chunks, because they're only created in the moment you segmentize this first level.
Okay, cool. Thanks.
And the point is, when you would calculate somehow the one list at the very beginning for all of them together, you would still just become the chunks on this level and would never be able to reach the other. And that's the reason why when you have the flat recursive, you apply the flat recursive once per pass. So that means when you would have an encoder, which when it's already segmentized beforehand and run the encoder on this one, you would still have 2 calls for the encoder, not just 1. But I believe this is still good enough because it's still better than having 100 calls. So that's somehow the trade-off between having the full flexibility of adding multiple paths and still having the possibility to have some speed up due to batching. When you now look for the ranker, where you somehow use the complex, could use a complex structure where we use this recursive context-aware mix-in, then we want to rank perhaps as the chunk of the chunks. Somehow first we want to get the sentences somehow in a good order, in a good ranking. Afterwards, we bubble up the results, the chunks, and then we bubble up the results of the chunks to the root. So we would have something like traversal path would be CC, then C, and then R. And here we have we get again an iterable, and but here we can calculate already everything beforehand, because it's already somehow the data structure is already beforehand there. But since it's an iterable, they are also calculated on the fly. So that means you get the first document set, as long as you are still doing it for CC. And then afterwards, you can use, once you're at the C level, which is down here, you can already use the values that are calculated up here somehow, and the new scores you can already use here, because everything is somehow done in place at the document level. And afterwards you get an R. So here the data structure looks the same as if you would just use one pass. Because this is an iterable and not a list, so it's not completely put into memory before all the calculation happens, but only on the fly. So again, comparing these two, for the flat one, you get somehow one call of the apply all functions per pass. And for the context aware, you have one call with an iterable where all of them somehow go in the order you define the passes. There is one breaking change for our aggregation ranker. The traversal pass for them must be leveled 1 up. So when we before had traversal pass of chunks, then we now need the traversal pass of root. That also makes much more sense. So before it was when I wanted to somehow score the documents on root level, I actually had to put a chunk there because the context document was on the root level. And that's why before we put in the chunk, but it makes much more sense that when you want to rank something on root level, you put there a root and not a chunk. So I believe it makes the interface clearer. It's just a breaking change. So whenever you had before a ranker which worked on chunk level and you see something is behaving really weird, most probably you have to change it to the root level. Or when it was chunk level to the chunk level, or when it was match level to the match level. So one level up. And to wrap it up, we have now two different new mix-ins which we can use. One for having allowing batching and much faster data crunching, and one for doing still operations where we need to adjust the data structure, where data crunching anyhow most probably wouldn't be possible. So what's next? We have now put this change to the driver level, but not yet to all the executors level. So we now have to propagate this change to the encoders and to the crafters and to all the executors that we have, that they either do the batching operation or not, depending on if the executor can do the batching operation efficiently or not. This will happen in the next weeks, or next week. Let's see how fast we are, that we somehow, for each encoder, but also the other executor. So that's not just encoder, this is also crafters and whatever comes, let's see. Perhaps also rankers. Each of them either supports the batching, or if it not supports them, works probably with it. Yes. Any questions so far? If not, then let me do one more thing. So before here we are somewhere in the implementation of the context array recursive mixin and the flat recursive mixin. And before here in this, we are in the Jina drivers and then in the init. So where the base driver is somehow defined. And before, the traverse function was also somewhere here. Actually, it was in the base recursive driver. I tell you nothing. There is nothing anymore. Oops, someone has enabled sound. Oop, who is it? Okay, anyhow. So before, somewhere here, the traverse function was, but now this was moved. And when you now give in, somehow get the documents with self.docs, what you get back is a traversable set. And this traversable sequence allows now the traverse, where someone here all the actual traverse logic is implemented now. Just so you to know somehow when you want to look, okay, how is this implemented? Here you see how the traverse itself is implemented. And now the document set, but also the match set and the chunk set use this traversable sequence.
Lewis, I think it's your mic.
Use a hotspot, can also mute. Okay. Yes, so that's somehow how it's implemented. And you see when you go to document sequence, document set, this will be renamed to document sequence soon because it's actually a sequence and not a set. This uses now traversal sequence. And the match set uses documents, so that's also traversable. That's why we can somehow go down not just in the root documents, but also in the matches and in the chunks. We can properly do these this traverse and get the reference doc as I explained before. Yes, that's it from my side.
Perfect. Thank you, Max. And do you want to stop sharing your screen and I'll throw my screen back up there? Right. Okay, can everyone see that?
Yes.
Great. So before we dive into community questions, I'd just love to give a big shout out to everyone in our community. We had our 1.0 release last month, and man, you guys got the word out there. We are so grateful. We got like 200 stars that week. We got over 30,000 YouTube video views. So thank you, thank you, thank you. Without all of you, that would not have been possible. So we love all of y'all. So now that that's out of the way, community questions. What have you got for us? Throw them out there.
I still have one demo for the multimodal.
Oh,
if
you do?
we have
Oh,
time.
Whoops. Yes, of course. Go for it.
Okay. Let me see. Okay, you can see my screen now?
Yes.
Yep.
Like the presentation? Oops. Yes. Okay. So, hi, I'm Susana. I'm going to be showing you some multimodal demo today. It's very short, so don't worry. This will be not painful at all. Yeah, so as you saw before with the demo from that Bo presented, there are some ways that you can search, and he showed you one way to do it. So you have text as input, and then you're seeing some as output. But it can happen that sometimes you want both. So you have like more refined input to query. So sometimes you have an image and you want to like upgrade it or refine it a little bit with text, or the other way. So this is what this example is about, and this is what multimodality is about. So I'm going to show you how it runs, but then you can also see you can run it just with this Jina Hello Multimodal. Just don't forget to install it first if you don't have it, but this is all you have to do. So it's very easy for you to run, and then you can play with it and see if you like it or so. So I'm going to share you how it looks like. I find it. Oops. Yeah. So I have it already running because it can take some time for it to index all the documents, so I didn't want to waste any time. But you can run it with Jina Hello Multimodal. So in this example, you can see here I have this picture of a guy, and I have this text here, and those are the results. But I could also change it here for a woman, and it will give me new results that could also look a little bit similar to the image here, or you can use a new image like this one, search for it, and then you're gonna have like a combination of both and the text. So it is of course not perfect, because here you can see this is just an image of one hand with one band, but here you can see a lot of fitness pictures, which come of course from this fitness text. So you could also tweak here if you wanted to have more, to have the results to have more input from the text or from the image. But this is, you can play with this, and you can see a lot of examples. So I would like to show you just a little bit how this works. Okay. This is going very briefly, just for you if you're interested in how this is happening. So as you can see here, we have our flow index. And here we have some comments saying that this is going to go into 3 separate ways. So the first thing we're going to segment it. And then we're going to have one, let's say like one branch or one pathway, like here it says, for the text, one for the image, and another one for the document itself. So if we have 3 different branches, then we're going to need, of course, also different YAML files. So the first thing that you can see here, it says that it's going to use a filter YAML file. If we look on it here, you're going to see that it's using this base executor, and you're going to see which kind of request this is going to need. So you can have different types. You know, you can index, search, update, delete, and control. And for this particular example, we're just going to use the index and the search. We're not going to use the others, but you can use it. So we have this directive here, use default, to like have a, let's say like a base for all of them, and just to have a specific ones for these 2 types. So this is for all the types that you could have, but we're going to refine it for the index and the search. And I'm saying here that I'm going to use the filter QL directive that comes from the language. So I'm going to use the filter QL, and I'm going to say that I'm going to use a meme type. I'm going to look up for this meme type. We say that we're going to need both text and images, right? So in this very first example, in the first pathway, I'm searching for text, which means that here in my index flow index file, I'm going to have to set this filter meme type to text. So when it comes here, it's going to take the particular type for it. So it's going to search and it's going to filter only by text. And then if you check the second pathway, it's also similar. So it's also using the filter YAML file, but meme type now is using image. So the rest is similar. I am just saying that the difference is that here I am going to filter either by text or by image, depends. And of course, each of them then it's going to use like specific encoders and crafters. So the text is going to, encode the text, and this image is going to use a crafter. But they're quite similar. And then at the end, I'm going to also index the document itself, and I'm going to join them all. And when I join them all, then I can then see the results, as you can see here. So here I'm saying the same. So we have our flow index, and then we have these 3 pathways. So one for the text, one for the image, and one for the document itself, and then we just join them. Yeah. And yeah, so I mean, this was just a very simple example or like demonstration of how you can use this demo. You can go and run it and yeah, see for yourself if you like it. That's it from my side.
Any questions for Susana? I guess not, but yeah, really impressive demo. Thank you. So community questions in general. We've had a lot of talks today. We've answered a few questions on those, but yeah, what else have we got out there? Anybody? Okay, I guess not much in the way of questions. So I've got a question for all of you. We already heard earlier from Giorgio what he's looking at using Jina to do. So other new people here, what have you got in mind? Emilian? I feel like a teacher calling on people now.
Yes, you really do. So I'm just interested in this like community building, and I'm a researcher at university in Munich. So I'm not a tech guy actually. You could call me like from the cultural perspective. And I was just wondering what you're doing here. And I heard from a friend that it's interesting that Jina is doing everything so publicly, and you can just join and look how demos are shared and how the work is done. So that's very interesting from a cultural perspective. So that's why I'm here. Yeah.
Oh, good to hear. Yeah, I'm the guy running the DevRel team, the developer relations team here. Mm-hmm. And we've also got my colleagues Pradeep and Paishan on the line. And that's one of the things that attracted me to Jina in the first place, is that, everything we do is open source. All the code is open for anyone to use, but we try to go above and beyond that. So we're also open governance. So we take feedback from the community. We try to be just transparent as we can about what we do. And we just try to be there for our community. If you see us on Slack, we're always asking questions to the community, gathering feedback, incorporating that into Jina as a whole. And
it's very, very interesting.
It's a
very unique
big thing for us.
Mm-hmm. Yeah.
Because without our community, we would not be where we are. Okay, who else is working on cool stuff or just playing around with Jina? Puria? Okay, Sairam?
Hey, Alex. Hello, everyone. So I have been following Jina since, I guess, 0.7.0. I'm not completely up to speed on the 1.0 release, but I have always been interested in this engineering all hands, where you very kind of bring everyone up to speed on what is the latest development and bring the community up to speed. So that's what brought me here. Apart from that, I have been looking at Jina as like a modular execution framework for not just neural search, but also for running various kind of multimodal workloads. So one of the use cases that I would be interested in is in medical documents. Like there is data, there is user data, which is also like their history, as well as there is data which is their, you can say some medical scans. And how do you integrate both of this in using the multimodal approaches that we use regularly for NLP and CV? So that is kind of the use case I would be looking at, and not specifically on Jina, but just researching around that.
Very cool. Yeah, if you post on our Slack about that, I'm sure our engineers will have loads of feedback.
Yeah.
Because multimodal is such a cool thing and something we're doing pretty well on.
Yeah, I was also impressed by the demo right now, and I'll definitely check it out.
Nice.
Yeah, I believe if you have medical things like I don't know, X-rays or so, it might be. I'm not sure if there are any models that already takes this data into account and are trained on this data.
Exactly.
I wonder.
Yeah.
That would be quite cool if someone in the research community somehow would dig up these models, but it's also kind of hard because it's super personal data, right? I mean, having bone fractures of someone, or you really need to anonymize this. It's hard even to anonymize, because if you have the CT of the whole body or so, I mean, how can you anonymize this? It's just the body of the person. But that would be quite impressive to see this have a model which one can play around there. Yes. So if you know any fields which we could poke there, that would be cool.
Yeah. Okay, Max. Thank you.
You're muted, Alex. You're muted.
Oh. And Louis or Louis? I don't know how to say your name. I'm sorry.
We can't hear you. You're unmuted, but we can't hear you.
That's right. Not a peep.
Hello, hello.
Hello.
There I am. Yeah. Hi, everybody. So yeah, it's Luis, but you can say Louis too because my sister calls me Louis. Yeah, I'm actually working on a new venture that's focused kind of like as a SaaS solo founder type of project, and it's in the personal knowledge management space. And so I'm looking at well, for myself to make better sense of my own notes, my own bookmarks, this type of data. And it's true that some of it could have you know, a multimodal aspect, especially with videos, but perhaps also images and even audio, you know, maybe like a podcast or something like that. So I'm definitely interested in Jina, and I've been following Jina since I think about the month of May or June, something like that, of last year. But I have never had the opportunity to really participate in the community. I would love to, you know, to tackle some kind of a small issue and contribute in some way. But I have to focus on my proof of concept first, and we'll see. But yeah, definitely Jina is something that I'm exploring. I need to explore as part of my initiative. Yeah.
Fantastic to hear that. Yeah, regarding like audio, we've also got an example project on our examples repo using the VGGISH, the Gigish. I'm not sure how to pronounce the name of the model.
Thank you. Thank you.
Our pleasure. And yeah, Uche, it's good to see you again.
Yeah, it's good to be here once again. Yeah, thanks. I have a question. Sorry, I should have asked earlier. I have a question for Susana. The data set for the multimodal example, like, is it like, what data set is it? Is it the same as the Flickr 8K or?
Actually, let me exactly. Any of you remember, guys?
I think it's called people image dataset. I think it's publicly available on Kaggle.
Okay. Because I'm also interested in the multimodal search part of it, and with medical imaging also. So.
Very nice. Yeah, it's really encouraging to hear so many people looking at using Jina for, you know, really good things that help people, help the world. I'm so happy to see that. Cool. And I'm not sure if Puri is back yet. Okay, I guess not. So any final questions? Any final thoughts from anyone, community, team? All right, silence is golden. So thank you, everybody, so much for coming here. I'll just throw up one more slide, which covers how you can find out more. So yes, as always, our repo is at that address. Well, on GitHub, github.com/Jina-AI/Jina. We also got our dashboard repo, JinaD, Hub, JinaBox, the whole works. If you want to start building your own first Jina app, but you don't know where to start, you can go to our examples repo and check out the Wikipedia sentences example. That's a really simple one that'll just download some sentences from Wikipedia, encode them into an index, and you can search that really quickly. If you're not already on our Slack, join us. We love to hear from you. And you can follow us on Twitter, JinaAI_. You can find us on LinkedIn. Yeah, all the cool places where the cool kids hang out. So I'll just say once again, thank you so much for joining us. Thanks for your community support. Like I said, we couldn't do this without you. And yeah, have a wonderful week, everyone.
You too.
All right.
Yeah, go ahead.
guys.
Thank you,
Bye,
everyone.
everyone.
Bye-bye.
See
Yeah,
See you
thank
next
you,
time.
everyone.
you guys. Ciao.
Ciao, ciao.